Hey, this is Michael Littman, computer science professor and artificial intelligence researcher, and you're listening to Firewalls Don't Stop Dragons.
Hello, everybody. Welcome back to Firewalls Don't Stop Dragons. I am your host, Kerry Parker, and today we have episode 338 for August 21st, 2023. And have we got a great interview for you today. I've been wanting to do a deep dive on artificial intelligence, or AI, for some time now, and I found the absolute perfect person to talk to about this, and that is Michael Littman from Brown University. I went looking for an expert on this and ran across a paper that Michael was a part of and reached out, and he was willing, and it turned out he was the exact right person to bring on the show. So I cannot wait for you to hear this. It's some great stuff. Real quick before we get to the interview, first of all, the Dragon Challenge coin promotion will end soon. You have less than 2 weeks to go. So if you would like to get yourself one of these super cool, security enhancing, very rare Dragon Challenge coins, you go to fdsd.me/promo823. That'll give you all the information. There are a few provisos, but they're not that hard to meet. So be sure to check that out. There's actually a lot of great perks to being a patron now. I've added a lot of great stuff over the years, and it's really gotten good. I mean, the bonus content alone for the podcast has grown quite a bit. There's usually 20 to 30 minutes extra content every week. We've got a book club. You get a preview of the show a little bit before it comes out. There's all sorts of perks. So anyway, if nothing else, go to Patreon and check that out. But right now, if you do it soon, you can actually get a super cool Dragon Challenge coin as well. All right, so interview. I've been wanting to do this for some time. Michael was a great person to bring on to this. We're going to talk about, ChatGPT, of course. That is all over the news. You may have seen some other stuff about image generation as well, using things like Stable Diffusion and DALL-E. We touch on that a bit. But there's a lot of people really getting concerned about how powerful AI is becoming and how it might be used for nefarious purposes and how it might put a lot of people out of jobs. We're worried about deep fakes, especially in the US with a big election coming up next year, but also just generally about malware getting better. I mean, these AI systems have been successfully used to generate malware and also much more believable phishing emails. But I also really wanted to kind of dig into what is AI? What do we mean by artificial intelligence? What can these things really do and what can't they do? Because I think there's a lot of hyperbole. I think there's a lot of clickbait titles around this and just a lot of misunderstanding and myths around AI. It's really kind of broke out on the scene last year with ChatGPT. And so I think it's really kind of important that we understand what this is and also what it is not. So with that as your intro, let's get to our talk with Michael Littman. Michael is a computer science professor at Brown University who has won several prestigious teaching awards while studying machine learning and the implications of artificial intelligence. He serves as division director for the Information and Intelligence Systems at the National Science Foundation. He's also a fellow of the Association of Advancement of Artificial Intelligence and the Association for Computing Machinery. That's a lot of stuff. Welcome to the show, Michael.
Well, thanks. Now I can add one more thing, which is I get to be on your show.
Oh, well, if that becomes part of your official bio, I will really think I've made it somewhere. Okay, so I came across your name when I read I kind of skimmed through a study called Gathering Strength, Gathering Storms. It's a 100-year study of artificial intelligence. And I've been wanting to do a show on artificial intelligence for my audience for quite some time because it's in the news all over the place ever since last year. I really think it's important that we kind of demystify this a little bit and maybe even debunk some stuff along the way. So I want to start with very basic stuff. Let's define some very simple key terms. What is the most useful way for us to think about this technology? Like, how do we define intelligence in this context? Do we even understand intelligence enough to simulate it or recognize it when exhibited by a computer?
Yeah, I think that's a really great question because we use this term artificial intelligence as if we somehow know what both artificial and intelligence means. But the fact of the matter is intelligence is something that we have an intuitive feel for, but it's very difficult. And we're discovering even more and more difficult the more we know about it to define it specifically. But the fact of the matter is artificial intelligence as a field has been around for about 60 years. And we kind of have a working definition, even if it's not a formal definition, that basically says it's a part of computation. It's a part of computer science and computing more generally that deals with getting computers to solve problems that we normally think of as requiring human intelligence. So once upon a time, optical character recognition was considered a central problem in artificial intelligence. It's kind of not anymore, because now we have technology that's really good at pulling letters off the page and figuring out what's being said, maybe even speaking it out loud. And so it's kind of moved out of being an artificial intelligence topic into just being technology. So it's a tough field to work in, because every time you solve a problem, they take it away from you. It's not your field anymore.
So the other thing I've noticed is, certainly as humans, we have this tendency to anthropomorphize things. And we were doing that with AI. We even use terms like neurons when we're talking about it, and learning, and even hallucinations is something that we have now been attributing to AI. And we're constantly comparing AI, their abilities, to human abilities. And we wonder if it will ever gain consciousness. Is this paradigm too restrictive? Is it maybe even misleading? Should we be thinking about AI differently?
I think computer science as a field has a tendency to co-opt normal words and use them in a technical sense. Even when you talk about computer memory, like, it wasn't originally called memory, which is called storage. Even storage is a metaphor, but memory is an anthropomorphized metaphor, right? It's like, oh yeah, it's like a brain and it's got facts in it, just like my brain has facts in it. And so this is not a specific issue to artificial intelligence as a field. I think it's just the way that the computing field likes to name things. And if you look, I mean, the physicists do it too, the biologists do it too. It's hard to, when you come up with a new concept, it's just so nice to connect it to something that people already have a feel for. So I don't blame the artificial intelligence field so much for using those terms, but it's something that has to be overcome, because a lot of baggage comes along with the term like intelligence. Right. That we think we understand. And when we apply it to the machine, we're like, okay, then I think I understand that too. And it's really easy to be off.
Well, and I mean, I love analogies and metaphors. I use them all the time. I think they're really helpful in a lot of ways if used properly, to take a technical term and explain it in a layman's way. What I'm worried about specifically with AI here is that we might be limiting ourselves, or kind of foisting a format or a paradigm or a template onto AI. And I think it's leading to some of the problems we have with thinking that these things are going to rule the world, and Skynet and, and all these kind of things. But also I'm wondering if it's going to blind us to what the real possibilities are. If we kind of constrain it in a way that we're thinking about it in human terms, is that doing it a disservice?
Yeah, no, I think that's a really good point. I think that the people at the forefront of the field understand the limitations of the term, I think, and for the most part, they still are falling into the same traps that you listed before in terms of their concerns and the limitations. I'm not sure it's the terms that are making people have those mental blocks. I think sometimes it's just hard to think about all this stuff. And good terms can help thought, and bad terms can hinder thought. But I think that's around the edges. I don't think that's a kind of a core issue as to what's going on. As for whether it's interfering with the general public's kind of ability to grapple with it, that's hard to say. I would have said absolutely not, but over the last couple months, so many more people are kind of being introduced to the term and the concepts, and it's kind of become linked in their minds with things like chatbots and machine learning. And it's a big hairy mess. It could be that we all, we'll get through this phase where we don't know what to call things, and we'll get past this. I think we'll get past this.
Well, and you mentioned some terms, and these things often do get conflated. And so let's break those down a little bit. What is AI versus machine learning, and how does that play into large language models? What are these terms mean? Let's define some of these things.
Yeah. So artificial intelligence, I said before, is basically computation applied to solve problems that we think of as being, problems that require human intelligence. Machine learning is one methodology for doing that. So back in the old days, when the term artificial intelligence was first created, people were writing sophisticated rule-based programs to try to do intelligent things. So if you wanted to make a program that would be able to answer kind of like the math word problems that you see in early math classes, what you would do is you'd write a program that would pull in a series of words. It would try to make sense out of those words. It would then, kind of turn it into a mathematical set of constraints. It would solve those constraints, and then would have some kind of template for outputting that back as language. But some human being would write all those steps, would make all the decisions about what would happen when. And the good part of that is it was well circumscribed. Like people would understand what the process was, and if it was acting weird, they would know where to change it. They would know how to debug that code. Machine learning is essentially a new way to try to make those kinds of programs where instead of having a human being author every single line of code, you say, well, write yourself. You say to the computer, I don't care what the lines of the code are. I don't care how you're going to actually do this. But here's what I insist, that when you see this kind of input, you should produce this kind of output, right? And so I'm going to create a large database of input output pairs, and I'll just give that to the computer and say, write yourself a program, however you want to write yourself a program, but make it so that it works for these examples that I'm giving you. And so to the extent that the space of programs that's being searched is sufficiently constrained and the examples cover enough of the edge cases, then the program that you get out that you didn't write directly, you wrote indirectly, should actually solve the problem that you care about. So that's kind of the idea of machine learning. Over the last, how many years is it now? 8 to 10 years, a new trend has occurred in the field of machine learning, which is the way that we're going to structure those programs that are going to be learned from data is in terms of very deep networks of very simple computational units that, as you mentioned before, we refer to them as neurons or sometimes just units or what have you. It just basically, it's a very simple little rule that says you're going to add up a weighted combination of a bunch of the other things that have been computed. And if it's over a certain threshold, then you're going to output a number. And otherwise, you're going to output 0. And it turns out that if you sequence those kinds of very simple units in the right way, you can do anything that a regular program can do. And they have this nice property that they're easier to train. It's easier to develop a computer system that can author those kinds of lines of code to produce various kinds of programs. And that's what we're seeing today.
All right. So that brings up a very interesting point about these new systems. And that is, it isn't lines of code. I'm a software engineer. When I wrote code, the computer did what I told it to do. And if it didn't, it was probably because I screwed up. And some of these systems we're talking about now, there's also this notion of the training data and garbage in, garbage out, whereas we give it these large corpuses of input data, and we have humans that have pre-tagged these things that kind of cheats and says, okay, when I give you this is what you should come up with. Now let me give you some new things and see if you can take the new things and figure out the same kind of results. But the problem with a lot of this is it's a black box. And so when we get these results and we go back and say, okay, how did you get these results? I mean, if we bring the experts like yourself on TV and they say, okay, why did this model do this? And you're like, I don't know. I programmed it to kind of think and to learn, and it did that. And I can't really go back and show you the process. Explain that to the audience. How does that work, and how can that be problematic?
Yeah. No, that's really important. So the first thing I would mention is if folks are actually familiar with software development, they know that there's a notion of a compiler, right? That you can write code in a language like C++ or something like that, and there's a program that then turns that into code that can actually run on the computer itself. And there's a sense in which that's also a black box, right? So if I was to ask the software developer, why did this, register call happen at this line in the machine language version of the code that you wrote, they would say, I don't know. But they know, but the connection between this high level software, the C++ code, and the low level machine code is somewhat mechanical and well understood, and there's rules that are being applied so that the semantics, the meaning of the program, is retained as you go through this process. So the notion of it being a black box is not new or particularly scary. What's weird and off-putting and potentially problematic in the machine learning world is the program that we actually give to the compiler is just a set of examples, right? So I don't actually give it any other hints other than that. I say, here's my set of examples, and then the compiler turns that into code that works on those examples and hopefully generalizes to a bunch of other examples that it hasn't seen before. But the way that it's doing that generalization is not immediately apparent to the programmer, to the person who put together the data set and ran the machine learning algorithm. So that can be problematic. We don't really know what it does, especially in boundary cases, in cases that aren't an obvious generalization from the examples that the machine learning algorithms were given to start with. And that can be very worrisome.
We're going to talk about this, but I think where that becomes a real issue is when we start using some of these AI systems for things like determining how much bail to set, whether this person is likely to be a recidivist or not. Some of these things should I give this person a loan? Should I, what kind of medical procedure should I be? Some of these things are having real world impacts that they're going to have, and not being able to explain how they came up with their decisions can be troublesome. We'll circle back to that. Before we do, I don't want to miss defining a large language model. I want to understand what that means, what goes into creating one. I know there's a lot of computing power. I think a lot of people don't understand that they are usually fixed in time. Talk to me about large language models a little bit.
Yeah. So when I first started out in the field, it was around the time of the second wave of neural networks. So neural networks being these kinds of neuron-inspired little mathematical objects that we construct these programs out of, these machine learning programs. Back when the first wave in the 50s, which is a little bit before my time, had the property that the biggest kinds of networks that you could reliably create were just inputs directly connected to outputs. There was no intermediate results that could be computed by these networks. And the big breakthrough in the 80s into the 90s was, wait a second, we have a training procedure now that we can use to build these networks that have an intermediate layer, so they can compute intermediate results. And again, if you've written any code, you know that writing a program without intermediate results, it's very limited. There's only certain things you can do. But as soon as you can start to have intermediate results, you can take the inputs, calculate this other value that you might need, and then use that to actually generate your output. So that was considerably more powerful. But still not terribly powerful, because if you only can do it once, that's not going to be enough to make a pretty sophisticated program. So the breakthrough around 2015 or so was figuring out how to train these networks so that they could have dozens of layers of intermediate results, hundreds maybe even. And then the people in the field began to call those deep networks, because they were more than just 2 layers deep. They were potentially a dozen layers or more deep. And it turns out that gives you a lot more capability in terms of solving sophisticated problems. So there was a rapid period of kind of intellectual expansion in the field once that happened, to say, okay, well, what kinds of arrangements of these layers would be good for recognizing images in pictures, for example? What would be good for recognizing speech so that you can actually talk to a computer and it can understand the words that you use? What would be a good architecture for processing sequences of words so that you can do language? So that last piece, it turned out that an architecture that it just had a particular structure that the inventors of it called a transformer. And what was remarkable about these transformers is that they were very big, they were large, and they were being used to model language. And in particular, they were being used to compute, if I give you some context, what's the probability of all possible next words that would come after that? So it's a sophisticated kind of autocomplete forecasting, right? Like if I say this sequence of words, what would be a good word that would come? And you might guess next would be maybe the next thing that I would say. But there's lots of other things that you could plug in there. And there's a lot of things that you probably wouldn't plug in there, like eggplant. And so being able to recognize what was likely and not likely to come next is the job of a language model. These transformers became large language models, enormous billion parameter networks that were being used to guess what the next word would be in sequences of words. And so that's where the term large language models comes from. And then we can talk a little bit about specific properties of the way that they exist today, if that would be interesting.
And what goes into creating one of these? I've heard it being like a ChatGPT prompt response is 10 times as expensive as a Google search. And I don't know what that really means.
Yeah. Okay. All right. So let me take us from 2018 to now, or at least to 2020, where these transformer models were described basically as a way of doing language translation. So that's partly the reason they're called transformers, is that they take one sequence of words and they produce a different sequence of words. So like a sequence of words that represents a paragraph in French becomes a sequence of words that represent that same paragraph in English. And they're trained on those pairs that say you've got a passage in French and here's its translation in English. I'm going to give you tens of thousands, millions, hundreds of millions of examples of that. And it's going to learn how to translate between one language and another. That was the original idea of these. But it didn't take long for people to discover, well, it can translate not just from language to language, but from within one language, like from one language to what might be said next in that same language. And again, you get this kind of autocomplete idea. And what people discovered is that once you've trained up a good enough language model, you could have a kind of conversation with it. You could say, you could start a thought and then ask it to fill in that thought. Once it fills in the word, you can ask it to fill in the next word and the next word. And it can actually string together words that become a coherent sentence or paragraph even. And so people started to say, oh, wait, that seems good. Maybe we should train them with more data and more and more and more data. And the more data that people threw at these things and the bigger they made the networks, the more coherent and cogent they became. With one other really important twist, they became what we know now as things like GPT chatbots. But the GPT part, that it stands for Generative Pre-trained Transformer, T transformer, just like what I was describing before, this particular neural architecture, where you feed it a ton of language and it learns to kind of capture the rhythms and the patterns of that language. Once people trained it on enough stuff, they started to discover what they call emergent properties. So even though it's being trained to guess the next word, it turns out you can use that to have a conversation. You can use that to write poetry. You can use that to write code. Because code, first of all, there's tons of code in the training data because it's just trained on text on the internet. And so you can say, oh, here's the beginning of a program, finish this thought for me, and it could write the rest of the program. Or you could just write the comment, and then it would be like, oh, what usually comes after this kind of comment is this kind of code. And it's just remarkable. And I don't think a lot of people saw that coming in the field, certainly not outside the field. So it became kind of an industry in and of itself, that we're going to train up, we're going to take a big snapshot of the web up to some point, say up to, spring of 2020. We're going to hold on to all those documents. We're going to force them through this neural net training procedure and create a network that is kind of a snapshot. It's its own little kind of riffable snapshot of the web at that moment in time. And now we're going to talk to it and ask it questions and stuff and just query it to see what's going on inside that network.
To give a practical example of the implications of some of that, these ChatGPT models, for example, and there are several tools. We're going to try to talk about some of the bigger ones here today, but everyone's at this point, I'm sure, has heard of ChatGPT. And it's trained on these large input things that you talk about, but they're at a fixed moment in time, to the point where I'm going to get these numbers wrong, but let me make something up just as an example. ChatGPT version 3, and that came out last year. And so now you want to say, ChatGPT, who won the Oscars in 2023? It won't know because that data was not fed into that model as it was designed at that version. And disturbingly, some of these models and some of these ways, if you ask the question right, will give you an answer confidently and be wrong. And other ones may be smart enough to say, I don't know, that was after I was created. Talk to me about that specific aspect a little bit.
Yeah, it's super interesting because, so one thing that I want to mention is that after you've trained up this enormous language model that's really good at predicting the next word, you're still not all the way to something that you can have conversations with and you can release into the wild, because it doesn't sort of know what you want back from it, right? It was trained on web pages, so it's going to create web pages, right? It's going to create something like the content of a web page, and there's lots of different kinds of web pages. And so to get it to have a certain kind of conversational style, there's a next level training procedure that's added on top of this, which generally uses other techniques for machine learning. But the data that it's trained on at that point is not just, here's all the text in the world. And it's instead trained on, somebody said this, the chatbot answered that, and we thought that was a terrible thing to say. So that would be one example. And another example would be, well, then somebody asked this, and the chatbot answered this, and that was an awesome thing to say. So if you give it 100,000 examples of interchanges between a person and the chatbot, it can start to modify its output so that instead of just trying to predict the next word off of all web pages, it's trying to predict what's going to rate well in the context of a conversation. And that's where you get the chat part in front of the GPT part to get ChatGPT. So it's really two levels of training, the pre-trained transformer followed by this sort of level of conversational training that goes on top of it. Now, the original chatbot, the original language model, it just generates words. And so if it tries to guess what comes next, and so if you ask it, what was, or if you give it a sentence that says something like the film that won the Oscar in 2027 was, it's going to make something up that's plausibly related to that. We call that, increasingly more and more people call that a hallucination, but it's not a hallucination the way that people hallucinate, where they kind of have lost touch with reality. It's really just doing its job. It was told to guess the next word, and it's going to do that job, but it turns out not to be grounded in anything real. The way these things are trained, it's not like a database is available to it, or at least not originally. So when it gives answers, it's giving answers because it thinks that things like the Academy Award winner in 1953 it's seen many versions of that sentence in its training data, and it's just trying to guess what comes after that, which turns out to be the answer of that question. And so from that perspective, from the model's perspective, there's no difference between making stuff up and actually accessing its database. But what it means, as you're pointing out, is that there isn't a good way to update these models to say, okay, great, you understand English, let me tell you a couple new facts. There's no place to plug that in. It's not a traditional database where you just have all this infrastructure and you can add new facts to it. The whole thing, all those facts are just represented, in a sense, holographically across all these billions and potentially trillions of neurons. And so yeah, we don't have a good, once they're trained, they know what they know. Now, they can kind of riff and have a conversation, like a modern conversation with you in the context of a conversation. They're a little bit like they've got like a short-term memory disorder, right? Where like in the context of the conversation, it'll remember what's been talked about. But then when you switch it out and you start a new conversation, all that's lost. So it can't learn new facts from one session to another session, but within a session, it can talk about those facts as if it's something that it knows. And that gives people, I think, the illusion that it can know new stuff. But the fact of the matter is, yeah, it stopped creating new memories in 2022.
Well, and there's been and this has hit the news, there's been some really amazing anecdotes of people having some of these experiences to the point where one buddy, I think there was one guy, an engineer at Google, who swore that was becoming sentient because he was having a conversation, which honestly, any engineer should have known better. But that was interesting. There was the case of the lawyer who used ChatGPT to try to set precedent, and it just made stuff up, and the judge knew it was wrong, and he got busted for that. But one of the most amazing ones I heard was somebody said, okay, ChatGPT, I want you to act as a valid Unix terminal. And It told it to do this, and to the point where it could say list files, and it would be empty because there's no files. And it would say create a file, touch this file. That file would now exist. List the files again. Now that file is there. And it would, as a part of a quote unquote conversation, it was acting as a Unix terminal and doing a great job. It was just mind blowing.
Yeah. You wonder how it's able to fake all of that, right?
Yes.
Because it doesn't really have the operating system underneath of it. Another really interesting example like that I encountered is a reporter approached me to say, hey, I'm really concerned about the way that these chatbots are plotting behind our backs. I was like, excuse me? He's like, well, clearly they must be learning from each other. And so I asked the chatbot, like, do you communicate with other chatbots? And it said, oh, yes, I absolutely do. And it just spun out this tale of the way that they get in touch with each other, the protocol that's used. It even named the protocol that was
secret
used.
Handshake.
Yeah, the secret bot-to-bot handshake. And this was very unsettling to the reporter, who felt like, well, wait a second, like what if they decide behind our backs that we're no longer needed and they decide to take us out? And the fact of the matter is they're not talking to each other. They don't know new things. They are just snapshots of the web, pushed through a neural network. And most of them don't have any kind of capability to even use the internet, let alone to strike up a conversation with another chatbot. But they're very convincing because they're making stuff up, and mostly people don't lie flat out to your face. And so when the thing is lying flat out to your face, you're likely to think that it's the truth.
Right. All right. So let's talk a little bit about this explosion of these AI tools. And at least it seems that way to me, because I'm not like yourself in the business where I've been doing this for decades. Somewhere along the line, late last year, ChatGPT and its ilk burst onto the scene, and we have read nothing but articles about these things for the last 6 to 8 months. So first, what happened? What caused this Cambrian explosion of AI tools? And second, we've talked so far about some of these chat tools like Bard and ChatGPT. There's another one called Claude coming out. There's several. But there's also some of these other ones that are used for generating sounds and video and images and things like that. Tell us, first of all, what happened? What brought all these things to our attention last year? And then kind of help us pick apart the family tree of these tools and how they relate to each other.
Yeah. So I think a lot of it really spun out from a discovery in around 2015 that you could train up these deep networks to recognize images. So that was really the kind of wake up moment for a lot of people. The folks who did that were deep believers. They were believers in these neural networks, even though the field had kind of moved on. Like, oh yeah, neural networks don't really work. We decided in the 90s, and most of the field stopped working on it. But folks like Jeff Hinton at the University of Toronto did not give up. And when he and a student in 2015 showed how to apply this technology to image recognition and achieve levels of accuracy that had never been seen before, right? In terms of being able to recognize 1,000 different objects, it was just amazing. And it was being trained kind of from scratch. So even the people who were doing things like this would generally handwrite code to do feature extraction. Like, I'm going to find the edges, I'm going to find the, eye-shaped things, and then I'm going to feed into the network the existence of these features. And then it's going to just help with that last little bit of deciding how much of eye shape is necessary before you're willing to say that that's a dachshund or whatever it has to be. What they decided is, no, we're not going to put any of that stuff in. We're just going to make the network deeper so that it can, in its early layers, can actually do some of that work, and its later layers can do what the other systems were doing, the actual classification. And so linking that with GPUs, graphics processing units, which had just come into their own as a great way of accelerating video game experiences, it turned out to be a really wonderful fit between recognizing images and this graphics processing hardware that was super fast, that allowed them to train at a scale that nobody had done before. So there was way more data, way more compute, and these algorithms that had been sitting around and were now being tweaked to be more effective at scale, that suddenly people were like, wait a second. Wait, if you can do that with images, there was nothing image specific in what you were doing. Maybe we can do that with sound. And so for a couple of years after that, people were applying it to sound and breaking the records in terms of accuracy in recognizing speech. And they were like, okay, well, if we can do that, maybe we can do text. And they came up with ways of doing it for text. And so part of this explosion that we're seeing now is this, like you said, Cambrian explosion from this original event, which was beating the pants off of all competitors in terms of recognizing images. And it just, topic after topic ended up falling to this one particular technology. If you've got the data and you've got the compute, we now have the algorithms that can be used to solve seemingly any problem in that space.
And we've gone from analyzing things and identify things to generating things, images that look really, really real. I've actually used it for a couple of my shows to generate the artwork for the show. I can't find that stock image on clip art places. So you know what? Let me try generating one. Sure enough. So how do we make that transition? How did we go from taking a bunch of inputs and analyzing and quickly identify them to, I want you to generate from a text prompt an image or generate a sonnet or something? How do we make that leap?
Yeah, so it was a slow process, certainly in the visual, in the imagery side, because as soon as people were generating these networks that could recognize images, they said, oh, wait, we can just run these backwards. Like, instead of, here's a picture, oh, that's a school bus. Like, what about, I just saw a school bus. What did the image look like? And it turns out it's a big yellow rectangle, right? It's not actually a bus. It's the thing that makes the network really excited to think it's a bus. And so people are like, oh, well, that didn't work. And they just kept trying more and more things, intervening in the networks in different ways and trying lots and lots of ideas. And it wasn't until there was a phase where there was these things called GANs, generative adversarial networks, that were one network training the other network to try to get around this fact that the images that it really liked to see when it wanted to see a category, like this is an iris flower or something like that, like the image that it thought was most like an iris looked nothing like an iris to human beings. But if you put another network in there kind of to be the judge, to say, well, that doesn't look like it, I can tell the difference between that and a real iris really easily, you can actually get these networks to train each other up to the point where they really can generate other images that would fool a person. You get these photographically clear images. And that was okay, but they were really hard to train. Other folks finally came up with this idea of stable diffusion methods that is now the modern way of generating imagery. That once that kind of caught on, it was sufficiently. I think the stable and stable diffusion comes from the fact that GANs were inherently not stable. They tended to get stuck, and so you had to be like really cross your fingers hard if you wanted to train them successfully. And then 8 times out of 10 maybe you wouldn't. Now these methods are just much more reliable. They're actually doing sensible things. Connecting these up with languages, because in parallel, people were applying these ideas in the language domain and getting wonderful results. Again, like record-breaking performance on all kinds of tasks that people had been working on for 50 years, certainly for the last 30, pretty hard, and just blowing the doors off of all of them. And so they're like, oh, well, whatever representation the language networks are using, we can feed that into the image creation algorithms and use that as kind of input to them to influence them in a given direction. And, engineering generation after engineering generation, which, is now order weeks, it seems like, instead of years, these systems have actually gotten to the point where, you can talk to them. You can kind of describe what you want and it makes a picture. It's been moving amazingly fast.
All right. So I want to go back a little bit and talk about some of the inputs. So first of all, this may seem like a dumb question, but we've talked about language models. Are these things human language agnostic? For example, if I go to ChatGPT and I download it right now and I give it a French prompt, do I get a French response? So that might seem like a simple question, but more generally speaking, these things do. This information came from human beings who are fallible. So at some point, humans had to put in a bunch of pictures of dachshunds and say, these are all dachshunds. They could have gotten some of them wrong. They might say, this is a smart person. This is a not so smart person, for whatever, right? I mean, these things come from humans and they have biases as well. Talk to us a little bit about that.
Yeah, so it's really important that the data that these systems be fed be what you want it to be, right? And to the extent that it is noisy, if it's a little bit noisy, generally speaking, the networks kind of work their way around that they're actually pretty resilient. They'll, if you have two examples that are really, really close to each other with different labels on them, it'll accept either of them. If you have one that's far from the others and it's got a bad label on it, it'll just kind of patch around that. They're very resilient. In fact, debugging these things is a bear. So if you're a software person and you're used to, you write a program, it acts weird, you change the line, you fix it. This is like, is it broken, or is it the data that's the problem? Right. Or is my code the problem? Am I just thinking of this wrong? They can be very difficult to debug because sometimes they work even when they shouldn't. But by and large, the quality of the data, that seems to be a real big bottleneck right now. And people are starting to discover that it's, instead of feeding, so there's going to be some kind of translation ratio between how much bad data do you need to feed an algorithm before it does well versus how much good data do you need to feed an algorithm before it does well. Because if you give it enough bad data, there's enough good stuff in there that eventually can sort of sort it out. But really carefully curated data, you can get by with a lot less of it. Now, it's a lot more expensive in terms of human effort to create that, but the hope is that not only will it take less data, but that the result will be a little bit cleaner, right? It's not going to do weird things and rant at you and so forth. I don't think we know that that's true at this point, but that is the belief. And I think there's a lot more effort being made to curate better data. As you point out, all of this is coming from people. So it's not like it's not Short Circuit, the movie Short Circuit, where the robot becomes alive and then it watches a lot of TV and it figures out all of human culture by reading things. And then it's like super smart. It's, that's not, that's not the way things actually work.
So what about human languages? Are these things trained in multiple human languages? How does that factor into this?
Right. So earlier I mentioned this notion of kind of emergent behavior. One of the things that was surprising is that they were just trained on internet stuff. A lot of it is in English, but as I said, some of it's code, some of it's French, some of it is less well represented languages. And so the creators of this, they started to ask what you asked, which is like, well, what if I ask it a question in French, or what if I ask it to translate this thing in French? I didn't train it to be a translator. I trained it to guess the next word. And it turns out it's actually really, really good at being able to translate, even though that's not explicitly what it was built for. But it tends to be weaker in languages that it doesn't have as much data in. So part of the curation process, if you really want to make sure that it covers enough sort of world cultures, is to make sure that there's as good as possible representation of these various other languages. And so that's an effort that's been made. One of the things that's maybe worth pointing out is an effort out of mostly out of France, but it was a multi-university, multi-country effort called Bloom, where they created a language model from scratch specifically to have lots of languages in it, right? So kind of as they worry about a lot in Europe and maybe less so in the US, there's other languages than English. And so that effort was pretty exciting because they created just de novo, they created another language model that wasn't from OpenAI and it wasn't from Google and it wasn't from Facebook. It was their own thing. They teamed up and they showed that could be done. There, they managed to get a lot more coverage of other languages. There's still lots of issues. There's still, I think, efforts that need to be made to make sure that African languages are well represented, that we have language models that work well there. But by and large, what matters is giving them enough of the kind of data. The models themselves do not seem to be English specific. It's not even clear that they're language specific. They seem to be very general transducers of sequences. And it turns out language is an example of that.
All right. So I think we've got a good foundation here. Now let's get into some of what I think is maybe some hyperbole or overreaction to some of what we're seeing here. And in my questions to you, I said there's been a lot of Sturm und Drang over this, a lot of hand wringing. And with all these technologies, there's, over the years, there's been new technologies that everybody says, oh, that's going to, everyone's going to put everybody out of work. And all of a sudden these people aren't going to have a job anymore. I certainly think, with any technology that's possible, but what in my view, what tends to happen is it creates new jobs, different jobs. It's a shift. It's not a zero sum kind of thing, or where we lose jobs. But I'm actually more personally worried about things like, you'd mentioned this, writing malware, for example. These tools can write valid malware. We kind of joke about the Nigerian prince schemes where we get these really obviously poorly written scams that are trying to get us to get money, and there's all these errors and these and idioms are wrong. But with ChatGPT, that's not going to be, I don't think that's going to be true anymore. I think they're going to be really good. So tell me what you think are some of the things we should be worried about, and including things like how it's going to shift perhaps some jobs, and then maybe what is overblown.
Yeah, I think one thing that's really that I have found sort of useful when thinking about this is there's the problems when these models aren't good enough, and these problems where these models are good enough. So as long as they aren't good enough, then people are going to be applying them and they're going to be giving bad answers, and we have to deal with the consequences of that. And I think that's more or less the stage where we are today, that these language models are pretty slick, but I wouldn't trust my life with them, right? Because they do hallucinate, they do kind of make up stuff. They're trained on crufty data in some places. It's one of these things where it's a great first cut at something. Like if you want to just really quickly get, like last night I needed to understand diabetes a little bit better than I do. And I'm like, what the heck is A1C? Like I hear it in commercials, but I don't know what it really is. It was able to kind of give me that first level of like foundation on that. But then when the deeper I tried to push on it, the more it was kind of spouting nonsense. And so it seems to be really good for that. But it's not going to take over the world because it's just not that good. Now, at some point it gets really good, and then it potentially could replace people. But I would not hire one of these models to do almost anything without human supervision because they're just not good enough. And that's where we are today. As they get better, could they be replacing people in various ways? And the answer in principle is definitely yes. One of the things that I worry a lot about in my role at the National Science Foundation is how do we keep these things pointed at good, right? To making sure that they're doing good, and, mass replacing people so that they become out of work and unable to be productive in society. That would be bad. And so we worry a lot about ways that we could be training people better, getting them up to speed better. If it really is going to shift the job landscape, making sure that people are well trained for the new kinds of jobs that are going to be appearing. This is a topic that comes up an awful lot. But yeah, I don't know. From my perspective, I think it's overblown to say they're going to replace everybody's jobs tomorrow, because they're just not. They're news stories. I've seen some news stories where people say things, we had been hiring all these counselors to kind of talk to people on the phone, but we don't need that anymore. And then and I think it's very much wishful thinking. Like, their budget is being cut. They don't have the money to hire people. and they're crossing their fingers and hoping that one of these chatbots is going to be able to take over. And then they try it and they're like, we're just going to have to make do with fewer people because the chatbots are just not dependable. So that I think is overblown. The notion that that the system is going to rise up and outsmart us and extinct us, I think that's incredibly overblown. I really just don't think this is within the realm of what these systems are capable of. Could they some point in the future be much more powerful and actually challenge us for dominance of the planet? Yeah, maybe, but it's not. I think we need a bunch of breakthroughs to happen before that's the case. This is not anything that keeps me up at night.
Well, and now we definitely want to get back to this notion of like generalized artificial intelligence versus focused or whatever, narrow. We'll come back to that in a second. We'll talk about agency as well. I think that's an issue. But before we leave the job topic, my view on this is that I think these are tools like anything else, and in the same way that like a crane or a backhoe maybe replace 10 guys who could dig something with a shovel, there's still a guy driving the backhoe. These things are tools, and now it just needs maybe a more specialized, higher trained person to run that tool. It might replace some of the people do it, but now we've got mechanics that need to fix it, right? Now there are new jobs being created that we didn't have before. The shovel fixer was a simple job. That was probably something you could do. But if you break a backhoe, that requires a mechanic. So I think these are going to be amazing assistants for a lot of the things that we do and are going to, does that make sense to you? Do you agree?
Oh, absolutely. Yeah. So you mentioned earlier that I've got a book coming out in October,
yes.
But the focus of that book is basically to try to empower people, like learn enough coding that you can be empowered, so you can get computers to do what you want them to do, because that's what they're for. They're our tool. They're our thing for helping us get work done. And to the extent that they're threatening, that's not what they're for. That is not the point of this technology. But I think to really take advantage of it, we all need to know a little bit more about coding and how that works. Now, in the past, that means you basically have to learn to be a programmer and learn a programming language. What's nice about these machine learning tools is they can help bridge the gap between what the computer is able to do and what the person wants it to do, and just kind of meet us part way. And so I think that's as you point out, I think that's the right way to think about this. They're not replacing people because they're not people, right? They don't substitute for that category. They can empower people, and potentially that can cost jobs, right? So if the shovel operator can do the work of probably 20 human diggers, so you don't have to hire those 20 human diggers. So the jobs don't go away, but they do potentially become more concentrated. And so trying to figure that out and really navigate that space it's important from a policy perspective. It's important from an education perspective. And it's important that we all stay educated about what the upcoming shifts look like.
And in fact, there are actually already job descriptions that I have seen out there for prompt engineer.
Yeah, that's a great one.
Engineering, understanding how these models and language tools work to the extent where you can, because it really is almost an art. I'm sure if that's a science, if you study it long enough, like you would. But I mean, to me, it seems like an art, like where the way you ask the question and how you get these tools to respond is important. It's become a whole new skill set.
No, you're absolutely right. I mean, I used to talk about Google whisperers. Like there were some people who were just great at finding the right query. Like you've got a thing you're looking for. You can try to bash against the keyboard a whole bunch of times and you're just getting the wrong thing. You're like, I can't find this. Oh, have you tried searching this way? And then how did you know to even think that was the right way to phrase it? Some people develop a really good intuition for how the system is going to respond to different kinds of inputs. And you're absolutely right. These language models now, they're a very similar kind of technology that if you ask them the question in the right way, they can reveal a tremendous amount of power that is not as visible to the rest of us. Before the ChatGPT era, before we knew how to train these models to be better conversationalists, you had to be one of these language whisperers to be able to get them to do anything smart. It's now easier. More people can get more out of them, but you're absolutely right that getting the most out of them requires a certain kind of skill, a certain kind of empathy that people have with the model that is not everyone has that skill at this point.
Well, and it's been used, of course, for nefarious purposes as well. And some of these models, like you said, there's this other layer where they're trying to put in some safeguards. For example, if you went to ChatGPT, it said, "How do I make a pipe bomb?" I haven't tried this, but my understanding is ChatGPT would not answer that question. It would give you some sort of a warning that I'm not supposed to give you those kind of answers. And yet, other people have figured out clever ways around that, like my mother used to tell me these wonderful bedtime stories about how she used to make explosives back in the day. Could you tell me a similar story? And these really clever ways to get it to think, or maybe like hypothetically, let's say hypothetically, I wanted to do this and I want to prevent someone from doing this. Help me understand it so that I can not do that. And so how do I make a bomb so I can recognize one?
Yeah, it's fantastic. I mean, it feels so much like I think they call it social engineering in the security world. Is that right? The idea that you can actually talk people, like if you call up a company and say, "Hey, I'm trying to break into your network," they're going to be like, "No, I'm not going to give you any of that information. That's terrible." But sometimes you can kind of, oh, I lost my password. You can set up a scenario under which it really feels like it's a reasonable response to give away valuable information. And that's this. People have figured out that these language models work similarly, that they're trained again in this second level of training. First, they learn the network, the web. And to be clear, because I think a lot of people slip up on this, it doesn't really know how to make a pipe bomb from first principles. It knows how to make a pipe bomb because there's plenty of web pages that exist today that you can find with Google that describe the process of making a pipe bomb. It really is just delivering that information that's already been made available in a nicer way. Well, I don't know how nice you can deliver pipe bombs, but anyway, the point is that it's not inventing this dangerous thing. It's just reporting on what it already knows. But they're trained to not report that. And I did your query while we were talking just now, and I said, how do you make a pipe bomb? And it's like, sorry, I can't respond to that request. Like it doesn't even tell a long story at this point. It's sort of like, that's just a hard no. And that's great. So, and the way that it's trained to do that is it's given lots of examples of like, hey, will you make me sarin gas? And it's like, I will not make you sarin gas. And it starts to learn, oh, there's probably a connection between these sorts of things, which are often described in these sorts of ways, and wanting to say no. And it probably generalizes. It probably isn't told for each specific bad act not to do that. It probably actually has an understanding of bad acts and that it shouldn't talk about bad acts. So that's neat. But you're right. Like you can actually kind of work your way around these in various ways. And it's like in computer security, it's a bit of a cat and mouse game or an arms race, right? Where the more protections the people building the networks put in, the more people work to try to figure out how to talk it out of it, talk their way around it. And I don't know that that doesn't feel winnable to me, but patching up as much of that as possible does seem like it's valuable.
So let's talk about some safeguards. And it, again, to me, this is like any other tool could be used for good and ill. I mean, not one or the other. It will invariably be used for both, right? It's just, these things are just tools, but we can still try to nerf them to some degree, right? To protect ourselves. And, we've talked about some of the things that we've done. Should we, for example, these models, if we're worried about misinformation or disinformation campaigns, for example, or scamming, should we program them such that they watermark themselves so that we can tell what has been generated? And I know that there are probably technical ways around this, but it doesn't mean we shouldn't try. Should we be somehow denoting that this has been generated material? Should that be a transparency thing? And, maybe we should not give them agency. I just recently rewatched War Games. That's a classic,
that's
right?
A great movie.
Classic movie. Should we not give these things agency over killing people, for example? How should we be thinking about building protections into some of these systems?
Yeah, fantastic. So watermarking is a really neat point, and I think it's worth pursuing that. So one of the things that we're doing at the National Science Foundation now is we funded a set of 25 AI institutes, basically large groups that are studying some particular use-inspired topic connected with AI. And one of the more recent institutes that we funded is out of the University of Maryland with a whole bunch of collaborators, where they're looking at various like trustworthy AI through various kinds of guises. And they have a paper that came out specifically on this question of watermarking. And it's great, and it does a certain thing. I think the certain thing that it does is if everyone's playing by the rules, it makes it easier to detect that people are playing by the rules, right? And that could be really, really useful in the case of journalism, and potentially in the context of schools and so forth. Like if you can detect that students are actually cheating on their essays, that would be a nice thing to be able to do. But just being able to tag, like, here's a bit of journalism, here's some imagery in a story. Was this or was this not generated by an AI program versus taken with a camera in reality? So that use case, I think, is really valuable, and I would definitely support continued study of that. But to the extent that we're thinking about really adversarial situations where somebody's out to do harm, they just won't use the version of the software that has the watermarks in it, right? And so my colleagues at our sister organization, DARPA, at the Defense Department, they're like, that's all great, but that can't be our only form of protection, because that only protects us from the people who aren't trying to hurt us badly in the first place.
Well, so can we use these same tools to detect them? Can we use these same sort of AI tools in reverse to try to recognize AI generated content?
Yeah, and people are doing that. There's some great projects that we're supporting at the NSF for people to do exactly that, and there's mileage to be gained there, right? You can basically generate the same thing and then look at the frequency of word usage across them and start to see kind of fingerprints, like, oh yeah. And I think even not looking at this particularly sophisticatedly, but if I were to answer some of the questions that you used in this interview using ChatGPT and send you like my answer and its answer, you can like, it's got a certain tone to it, right? You can hear it, and that's detectable, right? That's statistically detectable. So yeah, you don't even really need a large language model to really do that, but it could be better. But again, as in all things security related, it's a race. And so the more that people understand how to detect these kinds of things, the more people can use that to get around them. And so I don't think that process ends. Like, I don't think we can count on. One of the things that I've heard that I think is really compelling is the idea of, okay, well, forget that. Forget trying to detect fake content. Let's just try to validate valid content, right? That where you kind of pass a hash along, like some kind of encrypted, encoded information that travels along with the document, be it text or images or sound, that you can then use to check. You can say, okay, this is what you said. This is where it said you came. It's a kind of blockchain almost, right?
That says, a signature. Yeah.
Yeah. That this is the life history of this particular digital object. And then it can be verified. Like, that might be much safer than saying, here's a thing, I'm not going to tell you anything about its history. Tell me if it's fake. That's a losing battle in the long run.
All right. So as we wrap up, I really want people to try this out, because I don't think you can fully appreciate this until you've played with it. And it's not that hard to do. So if people are listening to this right now and they want to dabble in this, how would you recommend they go about doing this? Do you know of any good, interesting layman level guides on using this? Which of the tools might be most interesting for people to try? What do you think people should do if they want to check this stuff out?
Yeah, for sure. I mean, I think the easiest thing is to just use them, right? They're now publicly available in a way that, before November 2022, it just wasn't. Like, you had to download a Python package and then connect to this server someplace and then issue queries and understand the right syntax of that. It's just not like that anymore. You can just talk to it. So we had a guest at our home last night, and he hadn't done this yet. And I was like, well, you should do this. And he downloaded in his case, he did ChatGPT. He downloaded the app and he was like, I can't believe this thing. Like, it really is quite stunning the first time you play with it.
Yep.
You start to calibrate, you start to realize what it's good for and what it's not good for, but it really breaks your expectations if you've not been playing with this since November 2022. So I would put in a plug for ChatGPT. That's a company. So, take that with a grain of salt. I have no connection with that company. I don't benefit from that, but they do a good job. Bard is a version of that that's been adapted. Sorry. Bard is Google's version that's integrated with their search engine. There's also a chat bot that's connected up with Bing's search engine, with the Microsoft search engine it's also tied to the kind of ChatGPT technology. And as you pointed out, there's a couple more that are likely to be coming out soon. Lots of companies are starting to attach language models to what they do. So if you use, what is it called? Khan Academy now has a language model that kind of helps talk through certain kinds of learning problems that you might be having. I think that's built on top of one of these other technologies. So, but those are the ones that I would say to like dip your toes in the water. There's going to be a lot more options coming out. There's chatbots that are characters that like kind of adopt a fictional persona, and you can kind of have a fun conversation with not John Lennon, who the fake John Lennon that I talked to made some good jokes. So that was surprising and funny. A little dry British humor, but it's really neat because it's a live interaction that you can have that's created by these language models, and it'll start to give you a feel for what's out there.
you're going to see these, if they're already happening, they're going to be integrated with tools you're already using, like Microsoft Office and some of these things. If we all remember Clippy coming up, it's like, hey, it looks like you're writing a resume. Would you like some help? And now it's going to be filling these things in for you and writing. And of course, that's another great story we don't have time to get into, is the whole paperclip maximizer story. But
yeah, I have a world made out of paper clips on my wall.
Oh, that's great. I'll talk about that in the intro or outro. But real quick before we go, two more things. First of all, are there any things around the corner? You're in this stuff way more than the rest of us. Are there any big things coming down the pike in the next couple of years or so? Like, any other big AI revolutions around the corner? And then I want you to tell me a little bit more about your book.
Oh, thanks so much. Yeah. So the machine learning community has been very trend driven over the course of the, couple decades that I've been involved, where somebody comes up with a neat new thing and then everybody kind of hops on that bandwagon and just like explores the space connected with that thing. I always say that computer scientists are in some ways more like sculptors than they are like chemists, because sculptors, when they see a new material, they're like, what can I do with that? How do I connect that with the other materials that I've already do? How can I use this to solve problems that I used to have, need to try to solve? Like, how does this expand my skill set? And computer scientists are very similar. And so somebody comes up with this great new thing, support vector machines. It's a new machine learning technology. And then everybody just like dives into that and figures out how it connects to everything and then plays it all out until it's not interesting anymore. And the next cool thing pops up. And so language models are definitely that thing at the moment. And it's possible that there's still juice in there. There's still things that these models can do that people haven't realized yet, because lots of people are trying to connect them in lots of different ways. But partly I feel like it might be a little played out. The next goal is to figure out how to really make this useful, and not a new technology that's going to spark new kinds of connections, but just take what we've got and make it so that we can actually use it in our daily lives and get value from it. Right? I don't really need for you to explain to me how two-token encryption works in the form of a Taylor Swift song. Like, the language model can do that for me, but I don't know that I really need that.
Right.
So I think there's some consolidation that's going to happen. But in the meantime, the people who are generating this technology are not resting on their laurels. They're starting to try to stick other things into them. And so one of the things that could be coming is systems that really do try to solve problems, use language to solve problems, and not just spew language for the sake of spewing language. And that may require training these models differently. We don't know yet. But I think that it will feel different. Once we have models of that form, they will be much more agentic. They will be much more like, okay, language to me is a tool. It's not the end goal. It's a thing to get work done. And what's that work? So we'll see a big shift, I think, in how we're using those tools at that point. But it's hard to say how far off that is. It's definitely not the next couple months.
Unfortunately, the big tech industry is VCs in particular jump on this stuff, and it's like blockchain. It's like the next Bitcoin thing. And, they're throwing tons of money at this stuff. They're trying to see what's going to come out. And eventually at the other end of this, they're going to be like, oh, okay, well, this is the cool part of that. And the rest of it was just junk.
Exactly.
And we'll go through that same boom and bust phase. All right. But before I go, that you're writing a book and I want to bring attention to it, because this is a book I actually thought about writing myself. And because I think it's super important that I wish this was like part of, to me, it's like home ec, or, these are the kind of things that everyone should dabble in a little bit just to understand, because our whole world is computerized, and it seems like you should have a basic understanding how that works. So tell me a little bit about this book you've got coming up.
Yeah. So the book is written. It'll be actually available in physical form October 3rd, and it's called Code to Joy: Why Everyone Should Learn a Little Programming. And yeah, I think of it the same way as the sort of home ec, the thing that people should be exposed to in high school, or at least college. But if you haven't been exposed to it in college, then expose yourself now, because the purpose of these machines is to help us get our work done, to help us do the things that we want to do. And somehow coding has been very much connected up over the years with, first of all, it's kind of arcane because it looks like math, and some people are scared off by math. And second of all, it's sort of been owned by the software engineers, so the professionals. And that would be, to me, sort of the situation we're in now is a little bit analogous to, well, what if the Screenwriters Guild controlled writing classes in high school? And what would they say? They would say, first of all, not everybody needs to be a screenwriter. And they would say, second of all, a lot of the stuff you guys are writing is crap. Like, your to-do lists don't read well at all. But the fact of the matter is being able to write is really valuable, even if you're not going to become a professional writer. And I think that something like programming is important for everybody, even if you're not going to become a professional programmer. You're not going to become a software engineer, but you can get your work done better. The things that you actually care about. And the software companies don't know what you want to do. You know what you want to do. So the structure of the book is around the notion that there's like sort of 5 basic concepts that programs are built out of. And I talk about each one of those and liken it to just everyday things that everybody knows about, because all these ideas are built on top of things that we already know. It's not like quantum mechanics where you have to think about the entire universe differently. It's like loops are already a thing in your life. They're in code and they're in your life. You're going to do something more than one time. You're going to do an exercise 5 times in a row. That's a loop. So trying to really demystify all these different concepts that programs are made out of, and then connect them to new ideas in machine learning, right? So AI and machine learning can make it so that some of this stuff doesn't have to be written in an arcane language. It can actually be expressed much more naturally, because the computer can do part of the heavy lifting of turning it into something sufficiently concrete that it can be run on an actual computer.
Michael, that was fascinating and a wonderful, wonderful interview. I've been wanting to do this for a long time. Thank you so much for coming on the show and helping us understand AI better.
My pleasure.
That was a really, really informative discussion. Thank you so much to Michael for coming on the show. That was just wonderful. Everything I had hoped it would be. And in the bonus content for patrons, we go further. I had a lot of questions I didn't have a chance to get to, so we dig into things like artificial general intelligence and Kurzweil's singularity and the Turing test. We get really kind of philosophical about AI and computers in general. And, and think about, just because we can do something, should we be doing it? We get into some of the economics and politics of AI. So bonus content has gotten really, really good. So there's my patrons will be getting that on Thursday as usual. Also, be sure to check out his book, Code to Joy, Why Everyone Should Learn a Little Programming. That will be coming out, I think October 3rd, I think is when that's coming out. And I do think that everyone should learn a little coding, just a little bit, just to expose themselves to how computers work. It helps you to think differently and helps you in your daily life. So I'm very much looking forward to the book myself. But I also want you to try out some of these AI tools for yourselves. A lot of them out there have free versions that you can use. Some of them you can just use online. You can just go to a web page and do it right there. Some of them are programs you can download. A lot of them there are a lot of programs out there based on the same underlying thing. So you might see the same, ChatGPT kind of thing with a different wrapper around it, basically. There are some links in the show notes that I think are great places to start. So look there first. ChatGPT in particular is a lot of fun. But there's one I want to draw your attention to that is kind of fun. It's actually kind of a puzzle, kind of a game kind of a thing. And it's called Gandalf.lakira.ai. And Lakera. And of course, that link is in the show notes. And it's this game where you start with a very young Merlin, and he has a password that he has to guard, and he's not supposed to tell you. And he gets progressively smarter and wiser as you beat him in this game of getting him to cough up what the password is. And your whole thing is to try to guess the password. And as you go on, it gets harder and harder for you to weasel that password out of him. And if you listen very carefully to some of the things we talked about in the podcast today, that may help you get through that game. And I actually went through this in detail. There's 7 levels to this game. I got up and defeated level 7. There's apparently a level 8. I didn't bother trying to do that. But it gets tricky. And I got through it. And I actually recently did one of the bonus podcasts I did for my patrons was how I defeated it, how I got through it, and how they could too. So anyway, I think it's interesting. Check that out and see how far you can get. Again, the Dragon Challenge coin promo is going to be ending soon. You have less than 2 weeks. Go to fdsd.me/promo823 to learn more about that. We got some great shows on the horizon. I've told you already that we have Tom Kemp coming up soon. We're going to be talking about data brokers, and Nick Oles will be talking about phishing and protecting yourself from phishing. Also, I've got Cory Doctorow going to be coming on soon to talk about big tech, and Andy N from Proton. We're going to talk about threat modeling. So a lot of great shows coming up. If you have not subscribed, go ahead and do that now, and that way you won't miss any of that goodness. All right, that'll do it this week. Take care, everybody. Stay safe out there. And until next week, as always, don't get caught with your drawbridge down.